Okay, after reviewing section 1.4, which is about rational expressions, next section that I'd like to review is 1.6, which is a review of complex numbers. And there's a handout that's posted on D2L under handouts. It's a summary of all the complex numbers, so please go over that. That's in addition to the notes, of course. So if you recall, the square root of -1 is I if I square equals -1. So keep that in mind. Whenever you have an I, square root of a -1, you're going to switch it into I. And whenever you have I square, you're going to switch it into -1. So for example, square root of -4 is I root 4, which is 2I. Square root of -9 is I root 9, which is 3I. And square root of -b is I root b, as long as b is greater or equal to 0. So what is a complex number? Let's define that. A complex number, sometimes it's called imaginary number. There's nothing imaginary about it though. Is any number that can be written as a plus bi. So there's two parts. There's the a part, which is the real part, which doesn't have an I next to it, and there's the b part, which is the I part or imaginary part. Just like going from the number line to the rectangular system of coordinates. The x-axis is the real part, and this is the I part. So a plus bi is like having an ordered pair, ab, where a is your real number and b is your I part, and that's your a plus bi. Okay, just so you relate the complex numbers to the ordered pairs. Okay, so for instance, 1 plus 2i is like having the ordered pair 1, 2. This is 1 plus 2i. So we're not going to graph this, but just so you can get an idea what we're talking about. Okay, so now we know what complex numbers should look like. So we say two complex numbers are equal, like a plus bi equals c plus di, if they're equal, if they're exactly the same, meaning a equals c. So if a equals c and b equals d. So the I part, the real parts have to equal and the I parts have to equal. Okay? For example, if I have a question like this, find x if x minus 2 plus 3i equals -2 plus 3i. If you look at these two complex numbers, the I parts are equal, so these have to equal for this to be true. So x minus 2 has to equal -2, which means x has to equal 0. Okay, which means x has to equal 0. All right. Some examples of complex numbers. 5 is a complex number, which is actually 5 plus 0i. So basically, when we say 5, it's like having the ordered pair 5, 0 on the number line on the x-axis. Okay, that's 5 plus 0i, because there is no I part in this case. If you have, say, -2i, it's also a complex number because the I part, the real part is 0. So 0 minus 2i is like having a -2. This is 0 minus 2i. -2 on the y. Remember, this is the I part, this is the real part. Okay, so it's like having the ordered pair 0, -2. So this is called pure imaginary. It's like having a point on the y-axis, and this is called pure real. Again, pure imaginary because it doesn't have a real part. Pure real, it doesn't have an I part, or the I part is 0. Okay. So how do we add and subtract complex numbers? we just add like terms and write your answer in standard form. And when I say standard form, it's the a plus bi form. Okay, every complex number has to be written in just like an ordered pair, a comma b. This has to always be a plus bi. So for example, if you have 5 minus 2i minus 3 minus 3i, this equals 5 minus 2i minus 3 plus 3i. By distributing the negative, that would be 2 plus I if we add like terms. 2 plus I. Okay. To multiply two complex numbers, to multiply two complex numbers, we FOIL, and then make sure you change I square into -1, and then write your answer in standard form. So it could be foiling, it could be distribute, okay, depending on what you're timesing together, foil or distribute. So for example, if you have, say, 2i times 3 minus 3i, that's distributing. So it'd be 6i, 2i times 3i is 6i squared, but remember I squared is -1, so it's 6i minus 6 times -1. So the I square attached to any number will switch the sign of that number, so it's plus 6 plus 6i. Always write your answer in standard form. Standard form meaning real part, then I part. And if you look at this, -6 times -1 is giving you the 6, in case you didn't see it. Okay, so this is distributing. Then you could be in a case where you have to FOIL, example, as in 2 plus 3i times 3 minus 2i. So if you FOIL, you get 2 times 3 is 6, and then minus 4i for the outer, plus 9i for the inner, and then minus 6i squared, which is plus 6, because that's a -1. So 6 plus 6 is 12, adding like terms, plus 5i is your, and by the way, you could do all this on your calculator to check your work. Okay, let me just zoom in on this. So if you have a graphing calculator, it has an eye right there where you see the dot in the background. I is in blue on mine. So say you want to do this on the calculator. So you do left parentheses 2 plus 3. To access this, you gotta do second dot, and then right parentheses 3 minus 2 second dot, right parentheses, and make sure your mode, if it didn't give you a I, then you go to mode, and make sure when you go to mode your oh, it doesn't really have to be. Even if it's on real, it would still give you the I, okay? But if you put it on A plus BI, then it will make sure you do it. So this is fine. It's working either way. Okay. Let's look at another example. So if you're squaring a complex number, like 7 minus 2i squared. Well, to square anything, you gotta do it twice. 7 minus 2i, 7 minus 2i, and then FOIL. So that's 49, and then minus 14i for the outer, minus 14i for the inner, plus 4i squared, which is -4. So add like terms, 49 minus 4 is 45, and this is minus 28. Minus 28i. Sorry, I gotta zoom out. Okay. So 45 minus 28i. Okay. And if you're doing something like 7 minus 11i, 7 plus 11i, if you FOIL this, this is like having a minus b times a plus b, the difference of two squares. If you FOIL it, you get 49 plus 77i minus 77i minus 121i squared, which is plus 121. What happened to the I? It cancels out, and you get 49 plus 121 is 170, and to write it in standard form, it's plus 0i. So what happens when you times this? These are called conjugate pairs. Again, you can see why they're called conjugate pairs, because the I term changes, everything else is the same. What happens when you multiply conjugate pairs? When you multiply conjugate pairs, the I term disappears. So if you want to get rid of I, you times whatever expression you have by its conjugate. So if you have 5 plus 3i, you times it by 5 minus 3i, and it will get rid of I, okay? That's called the conjugate. So this is going to be used for dividing complex numbers, just like rationalizing the denominator. So to divide two complex numbers, you multiply the top and bottom by the conjugate of the bottom. Multiply the top and bottom of the fraction by the conjugate of the bottom. You multiply the top and the bottom by the conjugate of the bottom, and then simplify and write your answer in standard form. Simplify and write your answer in standard form. So if you look at number 40, page 64 in your text, how do we divide 5 minus I over 3 plus 4i? So basically, to write the answer as a plus bi, to write it like this is over 1. You gotta get rid of I from the bottom. And to get rid of I from the bottom, you gotta times by the conjugate of the bottom. And the conjugate of the bottom is 3 minus 4i. I don't care what's on top, you times by the conjugate of the bottom, okay? FOIL. So we have 15 minus 20i, and then the inner minus 3i, and then plus 4i squared for last, which is negative 4. Let's finish this, and then we'll go to the next one, to the bottom, okay? So we get 15 minus 4 is 11, and that's minus 23i. Now for the bottom, FOIL it. It's 9 minus 12i plus 12i minus 16i squared, which is plus 16. And you see what happens to the I. Cancels out, and that's exactly what we times by the conjugate. So we get 16 plus 9 is 25. To write it in standard form, we gotta split it up. So you would have 11 over 25 minus 23 over 25i. So you divide the 25 into each one of these terms. And if it's reducible, you should reduce it, but this one isn't, okay? So number 46, page 64, 1 plus 2i times 3 minus I over 2 plus I. So we have some work to do in the top first by foiling it. What do we get? 3 minus I plus 6i minus 2i squared, which is plus 2. And that's going to be 5 plus 5i. Okay, that's 5i, and then 3 plus 2 is 5. Now we're going to times by the conjugate of the bottom, which is 2 minus I, 2 minus I. Alright, so if we FOIL this again, we get 10 minus 5i plus 10i minus 5i squared, which is a 5 plus 5. At the bottom we get 4 minus 2i plus 2i minus I squared, which is plus 1. So now if you look at the top, you get 15 plus 5i all over. 4 plus 1 is 5. If you split it up, you get 3 plus 1i. Okay. Now what if we have to times, say, square root of -4 times square root of -16? Both of these are complex numbers. It would be a big mistake if you did this. Square root of -4 times -16, square root of 64, which is 8. We know this is wrong because you're timesing two complex numbers. It's not going to be 8. This should be treated as a complex number, which is 2i. And this should be treated as a complex number, which is 4i. 2i times 4i is 8i squared, and you can see why it's wrong, because the answer is -8 and not 8. Okay? So whenever you have I under the square root, treat it as a complex number. Okay? This product rule is only good for real numbers. It's not good for complex numbers. Okay. Next, we're going to do powers of I. So I to the 0 power is 1. I to the first power is I. As we know, I squared is -1. Now, if you go I cube, it's I squared times I, which is -1I. So we have I0, I1, I2, I3. I to the 4 is I squared times I squared, which is -1 times -1, which is 1. So that's the key, knowing that I to the 4 is 1. And you can see we started with 1, -1, -I1. Then I to the 5 is going to go back to 1, because it's I to the 4 times I, which is, it's going to go back to I. Okay, I to the 6 is going to go back to I squared, which is -1. I to the 7 is -I, if you check that, and I to the 8 is 1. So we can see that every multiple of 4 in the power is going to give me a 1. So that makes things easy for me. And if I do I to any power, as long as it's an integer power, you're going to get either 1, -1i, or -i. 1, -1i, or -i. Nothing else. And to do this, say I want to do I to the 201. Well, it's probably easier to see how many multiples of 4. So what's 201 divided by 4? So there's 50 multiples of 4 in there. So it's I to the 4, there's 50 of them, because 4 times 50 is 200, and the leftover is going to be what? Because 200, you need one more, so it's I to the 1. This is a 1, that's why we want to remove the multiples of 4. So what's 1 times I? And the answer is one of these, which is I. Let's do another one. Say I want to do I to the 1003. Again, how many multiples of 4? 1003 divided by 4, there's 250 of those. So 4 and then 250. That's going to be a 1. 4 times 250 is 1,000. So you're left with 3, because the total of 1,003. That's a 1. And we know that I cube is -I. So it would be -I. Okay, so practice those. And I showed you the handout. And that is the end of 1.6 complex numbers.